Good morning, everyone. My name is Snigdha Sarkar, and I am the CFD application engineer here at KETIV. I welcome all of you to our session today. Today, we will be covering geometry prep for CFD using SpaceClaim Direct Modeler. This session is geared towards anyone who is starting off with either CFD or SpaceClaim, or just looking to simplify their workflow in setting up a CFD simulation. So hopefully by the end of today's session, you'll be able to extract flow volumes from your CAD geometry. So let's start with the demonstration and talk about today's agenda. The first thing that we will be covering is repairing an imported CAD model in SpaceClaim Direct Modeler. The second thing that we will be covering is the flow volume extraction from this CAD for internal flow. And the third part will be creating enclosures around the CAD for external flow. Now, let me speak a little bit about the objective of today's AVA. My AVA today is geared towards CFD users and CFD usage. SpaceClaim, of course, can be used for a wide variety of analysis. Fluids is not the only area in which you can use SpaceClaim. But today, since I am the CFD application engineer, I will be focusing more on the functionalities from a CFD point of view. But our next session on SpaceClaim is being hosted by my colleague, Mr. John Dow, and he will be covering the basics for setting up an FEA simulation. With that said, let's start talking about SpaceClaim in general. For those of you who are not so familiar with the tool, SpaceClaim is basically a very easy to use 3D modeling solution. It can quickly repair and modify your geometry, so it is used for quick, rapid concepts, mostly used by analysts to set up their CAD geometry for either fluids or structural analysis. One thing to note is that SpaceClaim is a direct modeler. And when I say direct modeler, what I mean is that any changes or modifications that you make to your geometry, they don't get stored in your standard feature tree, like they would be if you were using any other standard CAD tool. So SpaceClaim is directed and designed more with the objective of helping analysts and quick designers. And that is where SpaceClaim is very easy to use. Without storing these changes, without storing these modifications, what you can do is start afresh from your current state of the CAD model. So if you were to work on a project and save your project and log out and come back in again, you can start afresh from your current state of CAD. You wouldn't have access to the changes and modifications that you made earlier. So with that said, let us begin with the demonstration. I will firstly be talking about the basic tools and functionalities that you would need to know in order to follow along with this presentation, and some tips and tricks that might come in handy for navigating in the workspace. So let me go ahead and share my SpaceClaim interface. So what you can see on your screen right now is ANSYS Discovery SpaceClaim version 2020 R1. I have an example case already loaded on the user window. And we will start talking about the basic mouse controls that you'd need to know in order to follow the demonstration. So right now I have a random CAD model on the design window, which is this space over here. If I wanted to select any entity, say a face, an edge, or a vertex, I can simply hover over it. Once I start hovering, the entity turns yellow. Once I click on it using the left mouse button, it turns orange. Turning orange indicates that that has now been selected. You can also verify the same selection using the message in the status bar below. If you wanted to select multiple entries at once, you could simply hold down the control key, and that'll let you select multiple entities at once. So right now you can see two faces. What if I wanted to select an edge? I could do that easily. So now it says two faces and an edge. I could even select a node. Now, what if you have multiple selections, but you want to deselect some of the entities that you have selected? If you wanted to deselect everything, you could simply click anywhere on the GUI and everything would be deselected. But if you want to deselect something in particular, again, hold down the control key and hover over the object to be deselected and click on it using the left mouse button, right? So easy to select and deselect. Now, how to navigate in this workspace, how to move your CAD, right? If you simply want to rotate your CAD, you can hold down the middle mouse button and it'll let you rotate the geometry about that particular point. What if you want to pan or shift your geometry? Hold down the shift button and the middle mouse button, and you'll be able to shift your geometry, pan it. If you want to zoom in or zoom out, hold down the control key and the middle mouse button, and you will be able to do the same. Right? Easy to use. Now, if you look at the ribbons tab over here, you'll notice that the select option has been activated because it's highlighted in gray. You will also notice that we are in the 3D mode right now. How do we know about that? If I hover over that, it'll say 3D mode. So we're in the solid mode right now. Since we are in the selection feature, let me talk a little bit about a very important and a very useful functionality that SpaceClaim has to offer, which is called power selection. So on the left over here in the structure panel, you can see that there's a single solid, which is the body over here. If you look at this panel, there is a selection tab. If you click on the selection tab, right now you don't see any options. But if I click on this hole over here, you will suddenly see all these options that SpaceClaim offers. What are these options? This is what you call power selection. The ability to select multiple entities simultaneously that have similar features. This hole has a certain diameter. It's 21.13 millimeters. What if I wanted to select all the holes in this geometry that have the same diameter? I could simply click on this option, and SpaceClaim would allow me to multiple select all the entities with that similar characteristic. And this is really useful because if I want to modify something really quickly, and I know that there are multiple entities that need to be modified, I don't need to perform that function individually for each and every geometry. I could simply say use the pull tool to modify the diameter of one, and that same modification can be observed for all the other holes in my CAD model. And this is a really important feature that you might need to use when you're trying to clean up your geometry and trying to make it watertight to extract a flow volume out of it, right? So let's go back to the select mode over here. And we will now talk about looking at the cross-sectional view in your CAD. Looking at the cross-section is always important, no matter what you're doing in a CAD tool. And SpaceClaim has some easy options to be able to visualize it. So let me go back to the structure panel over here. So if you remember, we were in 3D mode. If I want to look at a cross-sectional view along a plane, I will switch to the section mode. The moment you hit section mode, you will notice that these grids start appearing. If you're happy with the alignment of a grid, you can simply click on it. And you will notice a cross-section at that location along that plane. What if you selected the wrong plane and you want to change it? What if you want to change the location based on axis, or perhaps look at this from a different orientation? You could go to Move Grid. And what it does, it gives you access to this interactive axis that you can use to manipulate this cross-sectional grid. So for example, if I wanted to move this grid along the x-axis, I could simply hold down the left mouse button and move it along this arrow to translate the grid along this direction. If I wanted to turn the grid, by 90 degrees in some other plane, then I could double click these arrows over here, and you will see how easy it is to manipulate this grid. Now, why am I stressing so much on the cross-sectional views? Well, because when you're trying to extract flow volumes from your geometry, it is very important to ensure that your geometry is watertight, that it does not have any leaks. And how will you check if your geometry has leaks or not? You will examine the cross-sectional views to see if there are any gaps or not, right? So it's important to know how to be able to view the cross-sections in your geometry. So with that, let's move on to the next section, which is the main agenda of how to repair your CAD geometry in order to extract a flow volume from it. So I have a case already loaded over here, and I was practicing on this, so this has already been repaired. But let me quickly open the actual file. And while I'm doing this, it's also important to note that there are a lot of different CAD formats that are supported by SpaceClaim. You can simply click on this drop-down menu over here, and it'll show you all the formats that are compatible. Right. So let's just load the geometry over here. So let me just real quick with this geometry. Yes. So what you can see on the screen right now is a geometry that is dirty. This has a lot of disconnected surfaces. You can see that there are a lot of disconnected surfaces because of the appearance of the geometry. In SpaceClaim, surfaces are usually represented by a translucent visibility. If the surfaces were to form a solid object, then they would be opaque. You can also see the different surfaces in the structure panel on the left. These seem to be connected, but they're really not, because you have individual surfaces instead of condensing all of them into one single surface. Now, this is not suitable for extracting a flow volume. If I were to extract a flow volume out of this geometry, because the surfaces are not connected, my volume would leak and I would not be able to extract a region out of it. So what I need to do is fix it. How do I do that? I go to the repair section in the ribbons tab. Here you will notice something called solidify. You have three options under the solidify section. You have stitch, you have gaps, and you have missing faces. Now these three options are very easy to use automated functions that will let you automatically detect and fix any errors in your dirty CAD geometry. So let's go over them one by one and see what they do. I will first select the stitch option. When I do that, SpaceClaim automatically identifies all the different edges that are actually disconnected and can be stitched together. They're highlighted in red. So if I click on the green arrow over here, you will notice that all the different surfaces, they condensed into one single surface. That means they're now connected. Note that they're still not a solid body, it's still a surface, but at least now we have one surface instead of many. So let's go to the next option called gaps. When I click on gaps, SpaceClaim gives me a message saying that there are no areas found. Okay, no problem. So there are no identifiable gaps in this geometry. So let's move on to missing faces. Now, when I click on missing faces, you will notice that there are two areas that are highlighted in red. And this is a common problem with CAD geometries, right? You get it from the designer, and when you're prepping it up for analysis, you notice that either some face is corrupted, the rendering is not right, or maybe there's a gap, it's missing a face. So in those cases, use these options to identify those missing faces automatically. So I'm gonna hit the green arrow, which is the complete button. And the moment I do that, you will notice that this is now a complete solid geometry. Now, this geometry is not going to be used for volume extraction. This was just a simple example to show you the features and functionalities of this repair option. But it helps clarify the usefulness of these functions in being able to solidify an object, right? So also keep in mind, not always will these functions be able to detect an error. Sometimes a face may be so corrupt that there might not be anything to do in an automated manner to fix it. You might need to manually delete the face and render a new face in order to correct the problem. But these functions are useful in detecting errors that can be easily fixed, right? So at this point, I'm going to pause and see if there are any questions. Since this is a demonstration, I'd like everyone to be able to follow along with me. So let me just briefly look at the question answers. So someone is asking me, can you explain the section part once again? Sure, I can do that. So if I go to the design section over here, so right now, we don't have any cross sections. If I go to the cross-sectional, so we are in 3D mode right now. If I go to the cross-section mode, a grid automatically pops up, right? You can just click on that grid using the left mouse button, and that'll give you a cross-sectional view along that plane. If you were not looking for this plane, if you were looking to align it along some other axis, you could simply click on Move Grid, and it would give you this interactive cursor. So if you were to align it with the YZ plane, all you needed to do was double click on this green arrow over here, right? And then move it. So you can just hold down the left mouse button and move it, and you'll be able to see the cross section. You could look at the cross section head on by using the plan view. And hopefully, this answers the question. There was another question in the question answer session, how to create a new surface. You can create a new surface using different methods. You can either use the fill function to create a new surface in the place of a hole, or you could also go to the sketch mode and create a new surface or a new design. Now, I am not going to be covering the sketch mode in today's session because JD John Dow is going to be covering a lot on the structural analysis in the next session. But this is just for preparing your solid geometry for your CFD analysis. There is another question about how can we assign a parameter. That is a very good question indeed, and we can do that for sure. But that will require a little bit more time to explain. So what I'm going to do is I'm going to get back to you and answer that question by giving you some screenshots. Another session on sketch later on. Sure, we can definitely do that. I can connect with you later on to see if I can help clarify your doubts on sketching. Sure.
Hey, Snigdha, we had some more questions coming in, and I thought this one related well with the question about the section. Somebody asked about keyboard shortcuts. Does SpaceClaim have keyboard shortcuts similar to how most CAD programs do? Like if somebody wanted to do a section view, would they be able to use a keyboard shortcut to do that?
Yes, for sure. So SpaceClaim is extremely good in terms of shortcuts. So if you hover over any of the keys over here, you can see the shortcuts in parentheses next to it. So for example, if you go to section mode, it shows you X. If you want to go to solid mode, you can use D. So I have been using S and D frequently in this session today to just skip between the different modes. So right now, if I were to go back to the solid mode using the shortcut D, and I wanted to create a section, I don't really need to go to this tool over here. I can simply click X and it'll give me some plane. So I can just click on it and then later on modify this plane to suit my convenience. So yeah, I hope that answers your question, JD.
Yeah. And there was another question in concerns with units. SpaceClaim take the units from the CAD file, or how does it work with units?
So an easy way to kind of, so the default units right now is set to millimeters, but if you wanted to change the units as such, you could go to File and you could go to SpaceClaim Options. And you have an option of changing your units over here. So right now it's set to millimeters, but you could modify this to suit, you know, whatever needs you have as per your CAD.
Okay.
Right.
And one last question. Does SpaceClaim allow you the ability to understand the decisions that you're making in terms of measurements?
Oh, okay. Yeah, so like for example, if I am looking at this model right now, right? And I wanted to quickly gauge the measurement of any one particular edge or surface, right? So for example, I'm looking at this edge. I can simply click on this edge, it is selected, and it'll give me the length at the bottom here in the status bar. If I were to click on this hole over here, it would give me the radius. If I wanted some extra information, I could simply go to the measure tab over here and then click on measure, and it would give me a little bit more information about the entity that is selected. Right?
Excellent. Thank you, Snigdha.
Thank you, JD, for these questions. So let me jump into the next part of the demonstration then, and we'll have another Q&A session towards the end of this AVA, so I can answer some questions then as well. So let me talk about volume extraction. So here we were able to successfully correct this dirty CAD geometry and make this into a solid, right? So once we convert it into a solid, what do we do? So let us look at this example over here. Let me just close this real quick. So I have a step file over here. This is a simple mixing elbow. It's not very complicated. This is a clean geometry. It doesn't have any surfaces. This is already a solid, as you can see in the structure panel over here. And I want to create, extract a fluid volume from this geometry over here. If this were corrupt, if this were just, you know, a bunch of surfaces, then I would have to go ahead and repair it. But right now, for the sake of simplicity, let's just work with this example, which is already a clean geometry. If I were to extract the fluid volume from this example, what would I traditionally do? I would grab the internal surfaces and then cap it off to get the volume, which is fair enough and easy in this simplistic case. But as someone who has worked in the industry, I know that geometries are not always this simple. There are complicated geometries with small internal surfaces that are easy to miss. And you spend a lot of time and effort in cleaning up those geometries, fixing the leaks, fixing the holes, and making sure that you have a capped region. Now, SpaceClaim simplifies all that with the help of the flow volume extraction feature. So if I had to extract the flow volume, I'd go to Prepare, and I'd click on Volume Extract. When I click on Volume Extract, what it does is it gives me a prompt. It says, select faces that enclose a region. Now, which are the faces that I need to select? I know from a general physical understanding that this internal pipe volume is what I need to capture, right? So the faces that enclose that region would be the faces that are adjacent to the openings. So if this is an opening over here, this is an opening over here, and then this is an opening over here, then the faces that are adjacent to these openings are the faces that will enclose the region. So I will select this face, I will select this face, and I will select this face. Then I move on to the next prompt. Click the Select Seed Face tool guide to continue. Now, what is a seed face? Now, SpaceClaim needs to know exactly where is the volume, right? Is it internal? Is it external? Where is the volume that I want to capture? So a seed face is any face that actually forms the internal volume. So for example, I could select this face over here, and that would qualify as the seed face. I could even select this face over here. Anything that actually forms a part of that volume. So let me go ahead and select the seed face option and then select this face. Notice that the seed face is highlighted in blue and the capping faces are highlighted in orange. So that ways you know the difference. Now, before I hit the green arrow to complete the flow volume extraction, I wanted to show an important feature that you can see on the left over here. So it gives you an option of previewing the inside faces. So if I check this, it'll show you the volume that is about to be extracted. You can move the slider and see the path of the volume. Everything looks good in our case. The red volume is the volume that we do want to extract. So I'm just going to go ahead and hit the complete button. The moment I do that, what do I see? I see that there's an internal volume that has been captured. So let me just deselect the geometry part. And clean and simple, we were able to grab the internal path by just using 2 or 3 clicks with our mouse button. Now this is very useful when you're working with longer connections, more complicated designs, wherein you don't have the time to actually internally go in and select all the faces. This was really simple. So you can easily export this volume to another session, suppose in Workbench or Fluent or AIM, and get your simulation results real quick, right? So this was a very simple example. Let me show you a slightly more complicated example for flow volume extraction. So let me go ahead and deselect this. And I will open another case over here. So what you see on your screen right now is a turbocharger. Now, unlike the previous geometry, this is not completely clean. How do I know that? I know that because not all the surfaces are opaque. It's not completely a solid body. We see some surfaces over here, which you can also see in the structure panel. So let us go ahead and repair it. What do we need to do? We need to go to repair. We'll do stitch. There's nothing to stitch. Okay, all right, no problem. We move on to gaps. Again, there are no gaps. Let's do missing faces. And yes, there is a missing face highlighted in red. So we'll go ahead and click the green arrow. And as soon as we do that, we're able to solidify this, right? So everything is solid. So does that mean that my geometry is good enough for flow volume extraction? No, it doesn't. And I'll show you why. Just having solid components in your CAD model is not the only thing necessary for extracting a flow volume. As I have mentioned, it needs to be watertight. If there are leaks, the fluid is leaking. So the software cannot cap that region. So we need to make sure that all these surfaces are aligned with each other before we're able to extract a flow volume. So how do I see whether this is a closed volume or not, right? So this is where the section view comes in. So what I'm gonna do is I'm gonna hit X and I'm gonna click on this grid right here, okay? So I clicked on Z and that brought everything into focus. It's almost like a zoom to fit scenario. So let me look at this from another angle. So if you look at the cross-sectional view, you will notice two things. First, there is a gap between these two faces. That means the volume will be leaking out of here. So even if I were to use the volume extract option, I would not be able to do it. And the second thing that you will notice is that there is intersection. So you can see both these shaded parts coinciding with each other. If I wanted to get a better estimate of the interference in my geometry, I could go to the Prepare tab and I could click on interference. And what that does is it automatically detects all the coincident faces that are overlapping. So it'll show me highlighted in red the interference in my geometry, right? So we got to fix these two issues before we can move on to performing a volume extraction. Now, if I were to click on the green arrow here, we would be able to fix this automatically. But interference and the other features that I talked about are not the only options available to you. Sometimes the tool might not be able to detect everything automatically. So let's see how we can manually fix these issues in our model in case SpaceClaim is not able to detect it. So let me just hit escape to get out of interference mode and try to fix this manually, right? So what I'm going to do is I'm going to go to assembly. I'm going to use something called the align feature. This is basically a function that can help align surfaces based on a reference point. So it depends on the order. So let me just click on align. And let me do this. So I clicked on the first edge first and the second edge second. And what that basically did was it removed the interference. But once I do that, this green portion moves so that it's not interfering with the pink portion anymore. But over here, we can see that there is interference again. So let me just go ahead and move this back. So now we have no interference in our model anymore. And we also don't have any gaps because all the surfaces are aligned. If I want to double check whether there are any interference in my model or not, I'm going to go ahead and click on interference again and see if that gives me any errors. So it is still giving me one error over here. So I'm just going to go ahead and hit green button and see if that fixes it. So it has fixed that one problem area, right? So now I want to extract the flow volume. I don't have any more issues. This should hopefully work, right? So I'll click escape. And for the purpose of this demonstration, let's just ignore all the solid components inside the flow volume. So let me just highlight this volume, and then this volume. So I want to extract the flow out of these three, right? How do I do that? I will go to prepare. I will click on volume extract. I will select all the faces that are capping my flow region. So I will select this face over here. I will select this face over here, this face over here, and then this face over here, right? And then it'll ask me to select a seed face. So I will select a seed face. And as soon as I do that, we get a flow volume out of our components. Now note that this is a single volume, but we could have also individually extracted the volumes from all the components. So we would have 3 different volumes. And sometimes you will need to do that. Sometimes it is too complicated. There are too many openings. You might need to handle each and every component individually. So you would have more than a single volume. So if you have more than a single volume, but you still want just one flow region, what do you do? How do you transfer it to your analysis? Suppose you want to transfer it to Fluent or AIM. How do you do that? So now comes a very important feature that is crucial in transporting your SpaceClaim files to either Workbench or Fluent or ANSYS Mechanical. And that is called share topology. What share topology does is it'll make sure that your disconnected faces or surfaces or bodies share a coincident face so that the mesh can be conformal. So if I go back to my presentation over here, what I have here is an example for share topology. And I'm using this example because in my example, I just have a single volume, so everything is already connected. But in the snapshot on the slide, you can see 3 different bodies, 3 different volumes that look adjacent to each other, but actually they're not connected. They don't have contact points. They're not talking to each other. So if I were to transport this and create a mesh out of it, I would get a non-conformal mesh at the contact points. So in order to avoid that situation, what we basically have is the shared topology option. It'll create a shared topology between unconnected bodies so that the meshes can be generated at the contact points. And this is an important feature to keep in mind when preparing your geometry in SpaceClaim for CFD. So with that, let me just summarize the key takeaways from today's AVA. 1, SpaceClaim is a very quick 3D tool for doing geometry repair and geometry modification without storing a history of all the modifications that you made. It can be easily used for extracting your flow volume from complicated geometry, as we saw in the case of the turbocharger. And lastly, you can simplify your overall workflow and cut back on the time that you spend on correcting your CAD model, cleaning it up, fixing the leaks, etc., by using some automated functions in SpaceClaim. So this was one of the examples that I had shared in my last AVA, in which I had a simple pipe, and it took me hardly 1 or 2 seconds to extract the flow volume, create a mesh, and then very quickly do a simulation in ANSYS A. Right? So I hope that this AVA session was helpful and I was able to easily demonstrate the functionalities that SpaceClaim has to offer from a geometry prep for CFD point of view. And with that, I'll take a look at the rest of the questions. So if I just quickly share it over here. So they have something called the quick reference card in the online documentation, which gives you all the different mouse shortcuts. Due to the limitation of time, I am not able to cover everything in detail, but ANSYS documentation is extensive, and you will be able to find a lot more in the online documentation, but I can also share this with you. They also have something called mouse gestures in SpaceClaim. So you can use those gestures to quickly pull up some tools and menus that you use often. So that might be of additional interest to you. So with that said, let me take a look at some of the other questions that we had.
From the last slide that you covered, or the quick reference that you shared, Snigdha, there was another question that was asked from the audience, and it's about using a 3D mouse with SpaceClaim.
Mm-hmm.
I did answer that one privately with the audience member, but I would like to let everybody that's attending know that SpaceClaim does support 3D mouse, of different 3D mouse that have been certified. And if you guys are using a 3D mouse, I could share that list with you privately if you guys are interested. Please fill that out in the survey and I can give you that list.
Sure. And someone asked about, how is SpaceClaim advantages over Design Modeler. So SpaceClaim has these additional, features that will help you prep your model for analysis better than Design Modeler itself, right? So for example, I was easily able to extract the flow volume by just clicking on two uh, keys. I just selected the surfaces for capping and I just selected the seed phase, and boom, I have my internal volume, right? So it is a more intuitive, more easy to use tool with these added functionalities that will help you prep your model better. Like SpaceClaim also has a meshing feature, right? And we can talk about that in a later AVA session. So as far as preparation for analysis goes, SpaceClaim is definitely better than Design Modeler. Design Modeler is your standard CAD tool, and that of course will have all the modifications in the feature tree, and that can sometimes make your work a little bit more bulky. So for rapid design modification and analysis, it's better to use SpaceClaim. So yeah, another important feature that I wanted to highlight was, SpaceClaim also has the shrink wrap technology. So you can easily wrap a mesh around your geometry, even if it's not watertight, and export that mesh to Fluent or any other analysis software. So you can see that there are a lot of different advantages that SpaceClaim has to offer over a classical CAD tool. And with that, I see that there are a lot of good questions, but because the time restraints, I'll not be able to answer all of them. But what I will ensure is that I reach out to each and every one of you and answer those questions to the best of my abilities. I'll make sure I do that. But thank you all of you for joining us today. Please take a minute to fill out the survey if you can. It'll really help us, and appreciate all of you joining us today. Thank you so much. Thank you, JD.